Hello, everyone. So this is the training for understanding what is the preliminary alert, and we're gonna go directly to GW alert to understand, what it's gonna return in Slack and how urgent is the alert. So let me share my screen. So as you see, I am on GW alert channel, and so here GW, and I am the shifter tonight. You see I have candle behind me and I am waiting an alert. So let's see what is going on. So, oh, a new alert comes. I know it because it is bold, GW alert, and a new message arrived, you see. So let's read together. GW candidate. Why candidate? Because we never know if it is finally a true astrophysical event or not. Then we have 230511 CP, which is the name of the gravitational wave candidate, so the sources. The sources start by S, so it does not start by GW. It starts with GW when it is confirmed. But when it is a candidate, it's counted by S like super. We're gonna observe S like super. And then 230511 CP. So this event happened on 11 May 23rd. This is a test event. That is a bit old, but no, anyway. And then this is, I promise you, it is a preliminary alert. So this is the first message that you receive from 230511 CP. And number one, because the preliminary can be repeated several times. So it is the first time that the preliminary alert has been sent to you and to grandma. So now it's time to make decision. Then you have detected by H1, L1, V1, which means that this alert, the gravitational wave, have been detected in the three interferometers, H1 for Hanford, L1 for Livingston, and V1 for Virgo. Oh, so we are so lucky. So three interferometers, which means that the localization will be very precise, and it is an event that we need to pay attention. If it was like just H1, it's a one single interferometer detection, so it is not so that interesting. So then let's see about this section, time. So the trigger time, which means the T0, when the two compact objects has collided, happened as the name says, 2023-05-11 at 1722 UTC. So it's always in UTC, is not in your local time. And here you have the history of the events. So we have 3 days, 3 hours, 55 minutes. Is very strange because it's happened 11, so we are 15, so it's happened 3 days ago. The thing that you need to check first if this event happened after the time you are in, otherwise it is a test event, it is something weird. When time since T0 for preliminary is above 1 day, which means that we don't care about it. So you need to check if here it is less than a day. Again, this is an example. This is a test event, so it's not a good example. Anyway, so then we go to properties. And the first thing that you need to check is the preferred category. So BNS is for battery neutron star, and it is a very interesting event. It is our best event. So here we need really to wake up grandma and do our best, to follow up. Then you have a score. So the score is 2. You have score 0, so not good event, like not very interesting. 1, no. 2, oh yeah, why not? And 3 is golden. Okay. So why it is core 2? Because it is a BNF, so it is core 2. And then you have has NS and has remnant, which mean that has NS equal to 1, so which means that there is a possibility that there is a neutron star. So it is maybe there will be some matter around and some brightness. And has remnant equal to 1 would mean that we expect some matter and some light surrounding the event. So we need to follow up it. However, the thing that you need to really check is preferred category BNS and grammar score equal to 2 or above, 2 or 3. Then you have the SkyMap area, so 90% credible region. This is something very important because when it is below 200 degrees square, so here it is 671, it is very important. Here in this event is not so important because the 90% credible region is 670, so it's quite large, to observe. However, the 50% area is below 200 degrees square. That's why gamma score is still 2 and not 1, but it cannot be 3 because the 90% area is not below 200 degrees square. Then we have the distance of the event, how far is the event, and the distance is about like 248 megaparsec. So when it is below 200 megaparsec, the gamma score becomes 3, very important, because the distance, the event is quite close. So there is threshold below 200 megaparsec and above 200 megaparsec. And then you have this indicator which tell you how glitchy is the event. So coherence between detector versus noise. If it is above 0, above 3, which means that there is low chance that the event, there is high chance that the event is astrophysical. When it is below -3, it means that there is high chance that the event is not astrophysical. And here you have, in measurement, you have access to the LIGO Virgo page, public page, and here access to our Sky Portal page. I need to fill it that. And then I provide you a kind of summary. It is very interesting, but however, not well localized. Yeah, it is above 200 megaparsec. And far, yes, it is above 200, it is above 200 degrees square and it is above 200 megaparsec. So GROMA is going to compute the plan for the different telescopes, and if the area, the 90% area is still, if we don't reach 50% of the area, which means that it's not worth to follow up and the plan won't be sent to the telescopes. So let me summarize. I will stop the sharing. Let me summarize how it is urgent to follow up. So you need to check whether or not it is a BNS or NSPH category. You need to check if the distance is below 200 megaparsec and if the area is below 200 degrees square. Okay? If it does not fill this criteria, then the score will be less than 3, 2, 1, 0. If it is this criteria, then the score will be equal to 3, and you need to try to wake up all GROMA. If the score is 2, then the plan will be computed, and you can have access in upload, and this will be my next video. Thank you.